A missile traveling at nearly 2 miles per second. No warning, no second chance. And it is heading straight toward one of the most powerful warships ever built. That is not a movie plot. It is a very real threat facing U.S. aircraft carriers today. China already fields hypersonic missiles capable of traveling at speeds exceeding Mach 10. Russia has deployed ship-launched hypersonic weapons in active operations, and the Pentagon has acknowledged in declassified reports that China now possesses the world's largest and most advanced hypersonic missile arsenal. Every one of these weapons was designed with a primary target in mind: the American aircraft carrier. So what happens when one of these missiles is launched? What does the U.S. Navy do in the critical seconds between detection and impact? And here is the question few people are asking. Is the solution already in place? Or is the Navy racing against a clock it may not be able to beat? Stay with us, because the answer is more complex, more expensive, and far more surprising than most people realize. To understand how America defends its carriers, you first need to understand why hypersonic missiles are unlike any threat the Navy has faced before. Traditional ballistic missiles follow a predictable trajectory. Cruise missiles fly slowly enough to be tracked and engaged. Hypersonic weapons do neither. They travel at Mach 5 or faster, glide through the upper atmosphere, and can maneuver throughout their flight path. Unlike conventional missiles, their course cannot be accurately predicted simply by knowing where they started. At Mach 10, a hypersonic missile can cover nearly 2 miles every second. From the moment it is detected, defenders may have less than 20 seconds to identify the threat, assign a weapon system, launch an interceptor, and attempt a successful engagement. That is the challenge. Now here is what the United States has built to meet it. If you believe the men and women of the U.S. Navy deserve every resource America can provide, type U.S. Navy in the comments below. These sailors train for this exact scenario every single day, preparing for the moment when seconds could determine the fate of an entire carrier strike group. The first wall, the eyes in the sky. The U.S. Navy does not defend an aircraft carrier with a single weapon. Instead, it relies on a layered defense system consisting of 5 separate protective barriers, each designed to stop threats that manage to penetrate the previous layer. Think of it as 5 walls standing between an incoming hypersonic missile and the carrier itself. The first and outermost wall is one that most people rarely consider: the aircraft already in the air. Every carrier strike group maintains what the Navy calls a Combat Air Patrol, CAP. These patrols are typically flown by F/A-18E and F/A-18F Super Hornets, which remain airborne around the clock whenever the threat environment requires it. Flying above them is one of the most important aircraft in the entire U.S. military, the E-2D Advanced Hawkeye. The E-2D is not a fighter jet, nor is it an attack aircraft. It is essentially a flying command and control center equipped with one of the most advanced radar systems in the world. Its powerful AN/APY-9 radar can detect and track airborne threats at ranges exceeding 550 kilometers under favorable conditions. Operating at high altitude gives it a line of sight far beyond what any shipboard radar can achieve. This allows the Hawkeye to detect missile launches and incoming threats much earlier than surface ships can. More importantly, through a network known as NIFCCA, Naval Integrated Fire Control Counter-Air, the E-2D can instantly share targeting data with every ship, aircraft, and weapon system throughout the carrier strike group. The result is extraordinary. A destroyer operating dozens of miles away from the carrier can receive targeting information directly from the E-2D and launch an interceptor missile against a threat that its own radar has not yet detected. In effect, the entire strike group fights as a single, integrated combat system rather than a collection of individual ships and aircraft. That is the first major advantage America has built into its carrier defense network, and it begins with the eyes in the sky. The second wall, Aegis and the interceptors. The second layer of defense is the Aegis weapon system, and this is where the Navy's heavy firepower comes into play. Surrounding every U.S. aircraft carrier are Arleigh Burke-class destroyers, warships equipped with the highly advanced Aegis combat system, one of the most capable missile defense networks ever developed. The newest version of Aegis is paired with the AN/SPY-6 radar, a system estimated to be nearly 30 times more sensitive and capable than the older radar it replaced. That increased sensitivity is critical when dealing with hypersonic weapons. Unlike traditional ballistic missiles that travel high above the atmosphere, hypersonic missiles often fly at lower altitudes and maneuver unpredictably. Many radar systems struggle to distinguish them from atmospheric clutter, but the SPY-6 was designed to track precisely these kinds of threats. The primary interceptors used against hypersonic missiles are the SM-3 Block 2A and the SM-6. The SM-3 Block 2A, co-developed by the United States and Japan, is the Navy's long-range interceptor. Traveling at speeds exceeding Mach 10, it uses a technology known as hit-to-kill. Instead of carrying an explosive warhead, the missile destroys its target through direct impact. At closing speeds, this extreme kinetic energy alone is enough to obliterate an incoming threat. The interceptor is primarily designed to engage ballistic missile threats in the upper atmosphere or even beyond it. Recognizing the growing danger posed by advanced missile systems, the Pentagon included funding for additional SM-3 Block 2A interceptors in its fiscal year 2026 defense budget, underscoring the importance of this capability. However, the missile receiving the most attention from the Navy today is the SM-6. Originally developed as an air defense missile, the SM-6 has evolved into a far more versatile weapon. Navy engineers identified its potential and began upgrading it specifically to counter maneuvering hypersonic threats during the terminal phase, the final seconds before impact, when a missile is traveling at maximum speed and making its most aggressive maneuvers. In August 2025, the U.S. Missile Defense Agency officially certified the capability known as SM-6 Sea Base Terminal Increment 3. Following a series of successful tests, Missile Defense Agency Director Lieutenant General Heath Collins announced that warships equipped with this upgraded system would play a central role in protecting U.S. naval forces against future hypersonic threats. One of the most important demonstrations occurred during a test event codenamed Stellar Banshee, conducted on March 24, 2025. During the exercise, the destroyer USS Pinckney DDG-91 successfully detected, tracked, and engaged a highly maneuverable hypersonic target in the Pacific Ocean near Kauai, Hawaii. Lieutenant General Collins described the capability with remarkable honesty. He referred to it as the Navy's last look, one-shot opportunity, the final chance to stop a hypersonic missile before it reaches its target. That is not marketing language. It is a military commander acknowledging just how narrow the margin for error can be when defending against weapons traveling at hypersonic speeds. And that reality explains why the Aegis system, the SPY-6 radar, the SM-3, and the SM-6 have become some of the most important components of America's modern carrier defense strategy. The third, fourth, and fifth walls, the inner rings of defense. Now, this is where the story becomes even more interesting, and where most coverage misses the bigger picture entirely. The third layer of defense is the ESSM Block 2, short for the Evolved Sea Sparrow missile. The Block 2 upgrade was a major leap forward because it gave the missile something its predecessor lacked: an active radar seeker of its own. Earlier versions relied on a ship's radar to continuously illuminate the incoming target, much like shining a flashlight on a moving object so the missile could follow the reflected signal. Against a hypersonic missile traveling at Mach 8 or faster while maneuvering unpredictably, Maintaining that lock becomes extraordinarily difficult. ESSM Block 2 solves that problem by finding and tracking the target independently. The missile reached full operational capability in 2022 and is now a standard component aboard Arleigh Burke-class destroyers and other U.S. Navy warships. With an engagement range of approximately 27 nautical miles, it forms the third defensive ring around the carrier strike group. The fourth wall, RAM. The fourth layer is the RIM 116 Rolling Airframe Missile, commonly known as RAM. This system operates much closer to the carrier, typically within about 5 nautical miles. RAM employs a dual-mode guidance system. First, it locks onto radar emissions from the incoming missile itself, effectively homing in on the threat. Then, during the final moments of flight, it transitions to infrared guidance, tracking the heat generated by the target. The Block 2 upgrade significantly improved RAM's ability to engage highly maneuverable, low-radar cross-section threats. Unlike some other defensive systems, RAM is mounted directly on the carrier and several escort ships. It is an organic defense capability that does not depend on another platform to perform its mission. By this stage of an engagement, multiple interceptors may already have been launched, yet a sufficiently fast and maneuverable hypersonic missile could still be heading toward the strike group. That brings us to the final layer. The fifth wall, Phalanx CIWS. The fifth and last defensive layer is the Mark 15 Phalanx CIWS, pronounced CWIZ. This 20mm Gatling gun fires approximately 3,000 rounds per minute and is designed to destroy incoming threats at extremely close range. Phalanx uses a closed-loop radar system that simultaneously tracks both the incoming target and its own outgoing rounds, automatically correcting its aim in real time. Operating at distances of roughly 1 to 2 nautical miles, the system may have only fractions of a second to react against a hypersonic threat. This is truly the Navy's last line of defense. The Navy does not prefer to rely on Phalanx against hypersonic weapons, but it remains an essential safeguard. If necessary, it can engage automatically without requiring a sailor to pull a trigger. Electronic warfare, the invisible shield. Working alongside Phalanx is another critical system, CWIP Block 3, the Surface Electronic Warfare Improvement Program. CWIP is not a gun, and it is not a missile. It is a sophisticated electronic warfare system designed to jam, deceive, and confuse incoming missile seekers. Against radar-guided hypersonic weapons, a well-timed burst of electronic interference could disrupt the missile's tracking solution and force it off course during its final approach. It is not a guaranteed kill, but every disruption increases the strike group's chances of survival. The gaps, challenges the Navy still faces now, comes the honest part. America's hypersonic defense architecture is the most advanced naval missile defense network ever built. The 5-layer system represents decades of development and hundreds of billions of dollars in investment. However, defense analysts, the Congressional Research Service, and even the Pentagon acknowledge that important challenges remain. Gap 1. Saturation attacks. A single hypersonic missile is a serious threat, but potential adversaries are not expected to launch just one. The greater concern is a coordinated salvo, 10, 15, or even 20 hypersonic missiles launched simultaneously from multiple ships, submarines, and aircraft against a single carrier strike group. An Arleigh Burke-class destroyer carries approximately 96 vertical launch system cells. Those cells must accommodate anti-air missiles, anti-submarine weapons, land attack missiles, and defensive interceptors. In a large-scale saturation attack, the mathematics become challenging very quickly. Gap 2. The altitude problem. Hypersonic glide vehicles typically operate between approximately 40 and 100 kilometers in altitude. That places them below the ideal engagement envelope of the SM-3 while remaining far above the altitude where close-in defensive systems are most effective. This region, often referred to as the mid-course gap, remains one of the most difficult areas to defend. The Navy's long-term solution is the Glide Phase Interceptor, a next-generation weapon currently under development, with a projected deployment timeline around fiscal year 2035. Gap 3. Plasma Blackout. When a vehicle travels at Mach 5 or faster, the surrounding air becomes superheated and forms a plasma sheath around the weapon. This plasma absorbs and scatters radar signals, making precise tracking far more difficult at exactly the moment defenders need the most accurate data. Researchers are developing advanced sensor fusion and multi-radar techniques to overcome this challenge. But it remains a significant technical obstacle. The future, lasers, networks, and what's next? The future of carrier defense is not limited to interceptor missiles. The U.S. Navy is actively pursuing directed energy weapons, particularly high-powered combat lasers, as a long-term solution to the missile magazine problem. One example is the Helios laser system. Installed aboard USS Preble, the 60-kilowatt Helios successfully destroyed 4 drone targets during a demonstration in 2025. The appeal is obvious. A missile interceptor can cost between $1 million and $10 million per shot. A laser shot may cost only a few dollars worth of electricity. For a nuclear-powered warship, that creates the possibility of an almost limitless defensive magazine. However, today's laser systems are still far from being able to reliably defeat armored hypersonic missiles. The Navy estimates that power levels approaching 300 kilowatts or more may be required to effectively counter advanced anti-ship threats. Achieving that capability reliably at sea remains a work in progress. Information. The most important weapon. Beyond missiles and lasers lies something even more important: information. The entire 5-layer defense network depends on uninterrupted data flow between the E-2D Hawkeye, escort destroyers, fighter aircraft, and the carrier itself. The NIFCCA network is arguably America's greatest force multiplier in the hypersonic fight. Yet any military planner will tell you a simple truth: anything that provides an advantage also becomes a target. Electronic warfare, cyber attacks, communications disruption, and anti-satellite operations are all potential methods adversaries could use to blind a carrier strike group before missiles are ever launched. That is why the Navy emphasizes redundancy. If one layer fails, another takes over. If that layer fails, the next one engages. Carrier survival depends not on perfection, but on depth. USS Gerald R. Ford and the future of naval defense. The USS Gerald R. Ford, America's newest and most advanced aircraft carrier, cost approximately $13.3 billion to build. Rising nearly 9 stories above the waterline and powered by 2 A-1B nuclear reactors, it represents the future of naval warfare. Those reactors generate enormous electrical capacity, enough, in theory, to support future directed energy weapons capable of engaging the very missiles designed to destroy the ship. Ironically, the same characteristics that make a carrier such an attractive target, its size, power generation, and strategic importance, also make it uniquely suited to host the next generation of defensive technologies. No other warship in the world combines those capabilities on the same scale. Why it matters. The men and women serving aboard America's carrier strike groups train continuously for hypersonic threat scenarios. The systems protecting them are being upgraded, tested, and expanded right now, not in some distant future program. When the SM-6 sea-based terminal capability achieved certification in 2025, it was not a headline most people noticed. But for sailors deployed across the Pacific, it meant something very real. Their ships had a better chance of coming home. The hypersonic threat is real, and so is the defense America is building to counter it.
Outro. 5 layers of defense. Hundreds of ships, aircraft, sensors, and weapon systems operating as a single network. Advanced interceptors, electronic warfare systems, and future laser weapons that could reshape naval warfare. That is how the U.S. Navy is preparing to defend its aircraft carriers against the most dangerous missiles ever created. If you found this video informative, be sure to like, subscribe, and stay tuned. Our next episode goes even deeper into the technology, weapons, and people keeping America's Navy ready for every challenge on the horizon.